On January 6, 2025, at 11:15 a.m., David Morrow was enjoying the view of the Pacific Ocean from his apartment balcony. As usual, it was a normal day. At this moment, he noticed flames burning at the top of the Pacific Palisades, about 5 miles away from his apartment. As soon as he saw it, the fire spread rapidly, and within moments, thick smoke completely covered the mountain. Satellite images later confirmed that the fire had started in the Palisades Mountains. However, within a few hours, it had spread to areas including Eaton, Hearst, Kenneth, Getty, Skirball, and San Fernando. At the time, winds were blowing at 100 kilometers per hour. The wind direction was from inland to the ocean. This raises an important question. If the fire initially started near the ocean, how did it spread 30 to 40 kilometers inland against the wind direction? Welcome back to World Explorer's Corner videos. This wildfire has destroyed a total of 38,000 acres, 150 square kilometers. More than 12,000 buildings and houses have been burned down, and 180,000 people have been forced to evacuate their homes. This is the most devastating fire in Los Angeles' history. Every attempt to put out the fire had failed. Water bombers dropped 45,000 liters of water at a time, which seemed like just a few drops compared to the massive flames. Firefighters also used special fire-retardant chemicals, but these efforts appeared futile against the force of nature. California's frequent water shortages had also caused many fire hydrants to run dry. Firefighters and their equipment have been stretched thin due to the fire spreading across multiple areas. On top of that, when winds of 70 to 100 kilometers per hour blew over the flames, the fire intensified even more. Before discussing the real cause of the Los Angeles wildfires, let's take a look at California's history with wildfires. Over the past 25 years, California has been a hotspot for wildfires. In 2003, the Cedar Fire in San Diego County burned 273,000 acres. It started on October 25th and was finally extinguished on November 4th. In 2017, the Tubbs Fire burned 36,000 acres, also occurring in October. Later in 2017, the Thomas Fire turned 280,000 acres to ash. This fire began in December and lasted until January. On November 8, 2018, the Camp Fire burned 150,000 acres and was finally extinguished on November 25th. Similarly, in 2020, the Glass Fire burned 67,000 acres. It began in September and lasted until October. If we analyze the timing of these wildfires, a clear pattern emerges. They all occurred in the winter months. Interestingly, the current Los Angeles wildfire also started in peak winter. So, why do most of California's wildfires occur during the winter? The answer lies in a weather phenomenon known as the Santa Ana winds. These are hot, dry winds that blow through Southern California, particularly during autumn and winter. If you look at Google Earth, you'll see that to the east of California lies a vast desert, known as the Mojave Desert or the Great Basin. Sunlight heats up the desert, causing air pressure to rise. In contrast, the air over the ocean remains cooler, creating lower pressure. As we learned in 6th grade science, air moves from high-pressure areas to low-pressure areas. The greater the pressure difference, the stronger the wind. This is precisely what happens here. The Santa Ana winds from southeast California rush toward the ocean at high speeds. These dry and hot winds strip the moisture from vegetation, making the entire region highly flammable. Dry bushes and trees become instant fuel for any fire. When wildfires ignite in areas affected by Santa Ana winds, the strong gusts rapidly spread the flames. Burning embers are carried long distances, making it nearly impossible to control the fire. Normally, wildfires spread in the same direction as the wind. However, in the case of Los Angeles, the fire spread in the opposite direction. Initially, Flames were seen near the Palisades, which is close to the ocean, but later they expanded inland. To understand this, we need to examine an interesting phenomenon called the Mountain Wave Rotor. The side of a mountain where the wind first strikes is called the windward side, while the opposite side is called the leeward side. When the wind collides with the mountain, it creates a vortex effect on the leeward side. This vortex causes the wind to swirl unpredictably. The initial fire outbreak in Los Angeles was reported on the leeward side of the mountain. Due to the mountain wave rotor effect, air currents on this side moved in the opposite direction, which contributed significantly to the fire spreading inland. Once wildfires grow large enough, they start creating their own extreme weather effects. The U.S. has advanced technology to combat wildfires. Satellites continuously monitor fire size and movement, and artificial intelligence predicts the direction of fire spread. This real-time data is shared with firefighters to improve response strategies. Firefighters try to contain fires by spraying fire-retardant chemicals around the flames to slow their spread. However, in Los Angeles, the fire moved faster than they could control. Once one area was secured, strong winds would carry embers to new locations. I hope you enjoyed this video from World Explorer's Corner. Thank you for your love and support. See you in the next fascinating video.